Okay, we're ready to start with problem number 5. And this one, guys, I need to give you a little lesson about this. Because it can be confusing. If we knew that these angles are in the unit circle, then that wouldn't be a problem. But this is not in the unit circle. Okay? The y-coordinate of one point on the terminal side of the angle A is -4. First of all, picture that in your mind. You have a terminal, you have an angle in the standard position. So this can happen. When you have a terminal side, can be this in the first quadrant. Okay, this is the point, guys. These are coordinates, x and y. Okay, so this is x and this is y. This is your x and this is your y. And this is the angle they're talking about in the first quadrant. That'll be the hypotenuse, this is the angle, that'll be the opposite side, this will be the adjacent in the first quadrant. In the second quadrant, we have something like this. Let's say falls here. This is A, now x and y. This is x and this is y. In this case, you see x will be negative, right? And y will be positive because you're in the second quadrant. And the angle that we're talking about is this one. In the third quadrant, you're going to have, let's say this is A, x and y. This is your x and this is your y. The angle that we are talking about is this one. This is the angle. In this case, both of them will be negative because you are in the third quadrant. Right? In the fourth one, we have, let's say this is A, this is A, so A, x and y. In this case, x is positive and y is negative. This is y, x and y, right? And this is the angle, theta. This is theta in all these cases. This is going to be quadrant number 4. In quadrant number 4, the first coordinate is positive, the second one is negative. In this case, they are telling us in the problem the y-coordinate of this point is -4. Right? So the y-coordinate -4, if this point is in the fourth quadrant, so this is a situation for this. They're calling A to the angle. In the problem, they're calling A the angle. I just want to be consistent with the problem, but most of the time it's theta. So they're calling this one A, and this is the point. They're telling us the second coordinate is -4, and it is because it's the second quadrant. I mean the fourth quadrant. So you have -4 right here. And you know that x has to be positive because you are in the fourth quadrant, right? X has to be positive. They want you to find sine of A. Sine of A. Sine is opposite over adjacent. So y is -4, so I'm going to change this y by -4 because we already know the value, -4. And x, we don't know what it is. But we know that sine is opposite over hypotenuse. And they tell us the hypotenuse is 17 because they say sine of A equals to -4 over 17. So this is the opposite. That's the hypotenuse. So, how do I find cosine of A? If this is the situation, we're going to pay attention to this case, because it's the case we are working with, right, for quadrant. So how do I find cosine of A? I need adjacent, which is x, over hypotenuse. But I don't have adjacent, so what do I do? How can I find it? I have the hypotenuse, I have this leg, I'm missing one leg. What do I do? What do I apply? Pythagorean theorem. So that one is a squared plus b squared equals c squared, right? In this case, we say x squared, so we need to find x doing Pythagorean theorem is x squared plus negative 4 squared equals to 17 squared. So x squared plus 16 equals to 17 squared gives us 289, I think. Let's see. We already have all these answers.
289.
289. Thank you. Then from here we just have to isolate x. Subtract 16 in both parts. When you subtract 16, you get 273. X squared equals to 273. Then you get square root in both parts. And we know that x can be positive or negative. The actual answer is positive or negative. The square root of 273, which is 16.52. But since they tell us already what quadrant we are located at, which is the fourth quadrant, we know it's a positive one. So I'm just going to disregard this one because we are located in the fourth quadrant and x is positive. So that's the coordinate for that. So cosine, then we're ready to find cosine because if you put here the answer, the square root of 273. We could write this as a square root of 273 and find cosine. Cosine is adjacent, square root of 73 over 17. And that's the answer. Cosine of A will be the square root of 273 over 17. And well, in case they're asking you to round to the nearest tenth or whatever, then you go ahead from there. Continue with the problem.